Ladies and gentlemen, it's my great pleasure to welcome you to this session entitled Controlling Vector-Transmitted Infectious Diseases. My name is Olivier Desibourg. I'm the head of science scouting here at GESDA and also the curator of this summit. This session was supposed to be moderated by Suri Moon, the director of the Global Health Center at the Geneva Graduate Institute. But unfortunately, she is stuck at home with another transmittable disease, not vector-borne, this one, COVID-19, but she's all right. She just couldn't be here with us today. So I'm jumping in. So, albeit it's not the season anymore, at least in Switzerland, we'll talk a lot about mosquitoes in this session and the disease they transmit and how big that burden is. It might not be a big issue again in Switzerland, but as it has been shown in the video, I think there's no need to underline that the situation is totally different in many countries of the world. When one just thinks about the damages done by malaria, Zika, Chikungunya, and dengue fever, which will be at the core of the session today. So today we will be talking about a topic that fits perfectly with the vision of GESDA, that is to use the future to build the present. It is about a newly developed method to fight dengue fever that has been developed in the labs over the last 20 years, but also in the field trials. And a method that is now on the verge of possibly being endorsed by the WHO, the World Health Organization, but also to be implemented widely across the planet, provided the governments of the concerned countries decide to do so. And provided also that such big deployment schemes are actually financially supported, among other, by philanthropic institutions. So as you can see, we are right at this interface that GESDA is so much interested in, when a new scientific advance is more or less ready to be implemented widely on the planet, and when governments or decision makers have to make this step for the benefit of all who need it. So we will be talking about all these aspects today during the next hour. And I'm very happy to have with me on the panel today very high-level experts of the topic, but mainly from all the communities involved, dear to GESDA, meaning science, diplomacy, governments, international organizations, and philanthropy. We have today with us Arnaldo Correia de Medeiros, the Secretary General of Health Emergencies at the Ministry of Health in Brazil. We have with us Jeremy Farrar, the Director of the UK-based Wellcome Trust, and also a GESDA board member. We have Scott O'Neill from the World Mosquito Program, the CEO of the World Mosquito Program, coming from Australia for us today, or nearby France, because I know you live part of your time in France, and also Soumya Swaminathan, whom I'm sure you know, for those who live in Geneva, the chief scientist at the World Health Organization. We were also supposed to have with us Amadou Sall, from the director of the Institut Pasteur in Dakar, but finally he couldn't make it to Geneva. So let's start, and let's start with you, Scott. Maybe. Wait, I just introduced just introduced you. Let me start with you. Because why you? Because you're at the origin of this whole story, yes. Right? You developed this technology, this method, and we'll hear about in a second, to fight dengue fever, new method, which is now being implemented in the framework of the World Mosquito Program, of which you are the CEO. As said, this method is really at the core of the session we will discuss, and I think all of us would be happy to have a short presentation of what this method is and what the tremendous results you obtain in field trials are. So take the floor for 5 minutes and present us this.
Thanks, Olivia. So very quickly, to give a bit of background. And so as indicated at the beginning, we work on mosquitoes, but in particular one mosquito, Aedes aegypti, which transmits a number of viruses to people that cause disease and are hugely problematic, and the problem getting larger around the world. If we take just one of these diseases, dengue fever, and you can look on this global map here, you can see the extent of predicted case burden around the world. And you can see it's the tropics of the world, essentially. There are some areas where we have uncertainty, but generally the tropics. And the statistics on the bottom of the slide give you some idea of the impact. What I think they fail to convey is the social and economic cost, though, of a disease like dengue. When it sweeps through a city in a large outbreak, hospitals get overrun, children aren't in school, productivity goes down considerably for people that need to give care and then for convalescence afterwards. So the diseases that Aedes aegypti transmits are a big problem, and they're getting worse. So dengue, the numbers are here, but also in the family, if you like, of Aedes aegypti transmitted diseases, names you might be familiar with: Chikungunya, Zika, yellow fever, all transmitted by the same mosquito and causing disastrous outbreaks around the world. So I've been working, and while it's lovely to hear me get the credit of I'm the inventor or whatever, I have to confess that even though my ego is huge, there are some other people involved. And actually my role's become fairly minimal, I think. So there's about 100 people in our team at the moment around the world in our core team working towards developing a discovery we made a number of years ago. When you take a bacterium called Wolbachia and you put it into a mosquito, and it lives inside the body of the mosquito and actually gets passed from one generation to the next in the eggs of the mosquito, the presence of that bacteria stops all of these viruses from growing in the mosquito. They stop replicating, and if they can't replicate in the mosquito, they can't be transmitted between people. And so that was a fundamental discovery which we've been working very hard to try and turn into a practical intervention to use in the field. And really how we do that, given the biology of the system, is pretty straightforward. We grow in our laboratory, or in a factory if you like, mosquitoes that have this Wolbachia bacteria introduced into them. We grow them up in the laboratory and then we release small numbers of them into communities where they mate with the wild mosquitoes and pass that Wolbachia into the mosquito community. It then gets transmitted into the mosquito population and maintains itself without having to be reapplied. And then once mosquitoes have it, they're much less likely to be able to transmit viruses to people when they bite them. And so this graphic just illustrates the implementation of an intervention, if you like. We're looking along the horizontal axis, we're looking at time, and so on the left, starting at time 0, if you like, we have a population in a given geography that is all mosquitoes that can transmit these viruses to people. We then start a program where we release small numbers of mosquitoes that contain Wolbachia, they're the blue ones in this slide, and we get them up to a certain point of frequency into the natural population, and then we stop. And the Wolbachia is able at that point to keep on invading the mosquito population until virtually all the mosquitoes in a given area carry it, and then they continue to transmit it. So in Australia, where we did the first experiments, these were done 11 years ago, and if we go back to those populations, all the mosquitoes in those locations have Wolbachia 11 years after doing the intervention once in those areas. And there's no more dengue transmission in Australia. So we're currently working we have projects in all of these countries around the world. We're at a point now where we have covered around 10 million people that have received protection in different communities as parts of clinical trials or of demonstration projects. So it's on the edge, if you like, of scaling. And what we've been finding is very dramatic reductions in disease. So across the top here are cities around the world where we've been working, and then what we've been measuring for reductions in dengue. So the first two, Cairns and Townsville, Australian cities, we're demonstrating almost virtually a complete collapse of dengue transmission in northern Australia. There's really no local transmission occurring anymore in the north of Australia. Yogyakarta, we've measured a 76% reduction in a paper that was in a randomised controlled trial, which has been put into a paper this year in the New England Journal of Medicine describing the impact. In Rio de Janeiro and Niterói, we're in the process of deploying still. We have intermediate frequencies of Wolbachia in the mosquito population, but still seeing sizable reductions. We're measuring sizable reductions in disease. And then in other areas, the last 3 cities in Colombia, where we're seeing very similar results to Australia of almost complete knockdown. So this is for a disease that is a big problem. It's getting worse. We don't really have any effective tools for prevention. The tools we use are for outbreak control. The group of us that have developed this believe it has great potential. We're on the edge now of wanting to take it from 10.5 million at the present day to being able to be scaled globally so that the communities that can access it, that need it most around the world to reduce these arboviruses, diseases that are being a huge problem throughout the tropics of the world. So I might just leave it at that. Yeah. Olivia?
Just one precision question. The numbers in Vinlong and Rio are quite low. Is that because the trials are ongoing? Or
yeah, so in both cases, in Rio, well, different answers. In Rio, we're having some difficulty in getting high levels of Wolbachia frequency in informal communities, favela communities in Rio that are very challenging to operate in. And so we've been delayed in getting frequencies of Wolbachia up in those areas, which contributes to this number. And in Vinlong, we had a similar partial protection. We think there's a role in Vinlong for very high temperatures affecting the intervention, and so taking off some of the effectiveness in that location.
And I think one very important point that you went through very quickly, we hear a lot about gene drive and the idea to genetically modify mosquitoes as well.
Yes.
But this is different, right? We call it biologically modified mosquitoes. I think you could explain the difference between the two, because we've heard in the media recently with a UK firm called Oxitec that made some trial in Florida, among others. So this is different. How is it different, and why? And why is it important to be different?
So we're not using GM technology, if you like, which in a legal sense has a very specific definition, and that definition then influences regulation globally for the technology. What we have done is not manipulate the chromosome or the DNA of either the Wolbachia or the mosquito. We've just introduced them together, brought them together. This Wolbachia occurs naturally in almost 50% of all insect species on the planet, but not in this mosquito, the cockroach of mosquitoes, as my friend likes to call it, that lives around humans. But when introduced into it, has this effect. So and the two impacts of that are communities are much more accepting of the technology because there's not the fear around it, and regulation is different, and that can be both good or bad. So in some countries, there's no pathway for regulation that's clear.
We'll come to that in a minute. So thank you very much, Scott. Please take your seat. Let me now turn to you, Arnaldo Correia de Medeiros. So you present the Ministry of Health in Brazil, and Brazil is one of the most affected countries with dengue fever, if I'm correct. But you were also concerned because, as we saw, one of the field trials took place in Brazil first, and also your government showed a strong interest from the onset for this technology. So why is that? Can you tell us more about why your government really showed interest in this technology? And maybe also what were the challenges, because it's now being implemented at some barrios in Rio, if I'm right. So what are the challenges and so on? But maybe first, why?
The first why. First of all, I would like to say thank you to be present, to represent our Minister of Health in this high-level meeting. For me, it's a great opportunity to share the experience that we have done in our country. And for me, it was another pleasure to meet Dr. O'Neill, because he is the creator of these methodologies.
With his team?
Yeah, with his team, obviously. But I would like to say that the interest of our government to use the Wolbachia method is because, as you said, we have a high incidence and prevalence of the urban arboviruses in our country. We started this project, the pilot project, 8 years ago, around 8 years ago. especially in Rio de Janeiro, in the state of Rio de Janeiro, in 2 cities, in Niterói and Rio de Janeiro. Basically, we focus on in Niterói and in Rio de Janeiro, in some neighborhoods in Rio de Janeiro. And for why we decided to use the Wolbachia method, because I'm not explaining, because we had a lesson, a marvelous lesson, explaining of the method of this, but the problem is, the question is that we decided to invest, the Brazilian government to decide to invest in this project because basically it's sustainable. Basically it is sustainable. I would like to say that, I used to say that normally we have reverse logic, because we are accustomed, we are used to see killing mosquitoes. Mm-hmm. And with Wolbachia, we are releasing mosquitoes. So it's quite different to change, to explain to the population what is going on. Because it's quite important to diverse communities to understand what is going on, because we're not killing the mosquito, but we are releasing in the environment mosquitoes with Wolbachia. Mm. And that's quite strange for the population. What is this Wolbachia? What exactly Wolbachia is? Is this bacteria? Is this some disease or not? So we need a lot of instructions with the population as well. But the success that we had in Rio de Janeiro was so good, so strong, the first result that we had, that we did a make expansion of this project. Not only in Rio de Janeiro, but we have more in 3 states in our country. As everyone knows, here Brazil is a huge country, and now we have a project in the northeast of the country, another one in the central, and another one in the Minas Gerais, southeast as well. Mm-hmm. So we have 4 sites now, not only in Rio de Janeiro, but 4 sites now in our country, and we are understanding and studying the results that we are going to control as very important vector, because the Human arbovirus is quite important for our country.
But still, the technology is or was at the time experimental. So what made you take this decision? Okay, let's try.
Let's try. This is a very important question. This is very important to say that our government invests so strong in new methods that can reflect a good result for the public health. Because our concern is to give our population the best public health that we can do for the population. So we decided, even so, a new methodology, as you said, but we decided that it's quite important for all of us to invest in this. During all these 8 years, the Brazilian government invests $3.6 million in this methodology. So it's a lot of money for we understand it, for to give our population a sustainable methodology for we control human arboviruses.
Soumya Swaminathan, so you're representing WHO here, and obviously for you, dengue fever is a major burden on the planet. So, and you might play a big role in deciding or not to endorse that new method, right? And if I'm correctly informed, there is now a process, a revision process inside at WHO, of which the results might be an official endorsement of that technology. So why is that challenging to you? Because it's an out-of-the-box idea, right? It's new. So what challenges are it posed to regulators to address that question? How do you work? What's that process about to decide to endorse? Because this endorsement at the end will have such a strong weight on the decision of other governments to decide or not to implement the technology as well. So how do you manage that?
Yeah, so maybe I can briefly take you through the process that WHO uses for guidelines on different health topics, including on vector control. And there have been changes in the last 10 to 15 years in the way that this has been done. And in fact, 2007 was, I think, a watershed, because before that, a group of experts used to come together and make a guideline. And there was a lot of criticism that this wasn't ideal, and it was based on an opinion rather, expert opinion, rather than on the evidence that existed. So from 2008-9 onwards, we have a very good process, which has recently, we've further made some innovations in how the evidence is reviewed. I know this group here is talking about artificial intelligence, and that also has a role to play basically in reviewing the evidence or the data that's coming out, because to scan the global literature itself is a big task. And so AI could play a role in flagging that there are new studies or new trials. And then there's a systematic review done, and what we're calling it now is a living systematic review. That is of all the existing evidence. Now, in this case, there isn't that much of evidence. There's a randomized trial, and there are a few other non-randomized studies, but that's fine. All of that evidence is collected and it's graded. A randomized trial is obviously the highest level of evidence. Now, especially in a situation like this, where behavior of vectors could vary from year to year, it could depend on climatic conditions, the population behavior could be different. There could be many factors that affect, and that might actually affect the results of an intervention study, right? That's why you need a control group, and if it's randomized, it's good. If it's not randomized, then the quality of the evidence perhaps is a little less. But in some cases, you cannot do trials always. Double-blind randomized would be difficult in a situation like this. So you look at the evidence, you grade that, and then it goes before a guideline development group. Now, this group has been actually looking at, I think since 2014, looking at the data that's coming out of WML and also guiding. The other thing that we do is we guide the developers as to what kind of studies need to be done in order to establish a public health impact, because eventually the science is very interesting, but what you want is a public health impact. It also has to be cost effective, it has to be equitable. We look at many factors before the guideline group actually recommends, and then they make either a strong recommendation, a conditional recommendation, or a weak recommendation based on the evaluation of the evidence. So in this case, it's what we call the VCAG, or the Vector Control Advisory Group, which is run by 3 WHO technical departments. The vector group that sits within malaria, the NTDs, the neglected tropical disease group, as well as our regulatory and pre-qualification, because you need a policy guidance which comes out of, in this case, it would come out of the malaria and the NTDs group. Of course, we're talking about Aedes here, but for other mosquito interventions, for malaria, obviously, they're involved. And then the pre-qualification and regulatory team would look at the safety and quality of the product and make a recommendation on whether it can be used or pre-qualified. So that's the process that's used. And the guideline development group is very much looking at the data. They will have a meeting again before the end of the year, so we expect that there'll be a recommendation. But whether it'll be a strong or a conditional recommendation, we have to wait and see. But the good thing about the living approach is that it's updated. And so it's possible that in 6 months, a lot of data comes out of Brazil, other countries. The recommendation could then be updated as well. And this is one of the innovations now recently that we've made in our guideline process.
Thank you very much. Jeremy, finally to you. So besides being a GESDA board member, you're also heading a very important philanthropic institution, the Wellcome Trust. But besides that, you're also a specialist in that field, right, in tropical medicine and among other in dengue fever, if I'm right. So before the follow-up question, what do you think of this methodology as a specialist?
If GESDA was established, so I've got a few sort of declarations of interest here, as you say, so I should be careful which hat I'm wearing when I say what. GESDA wasn't in existence, actually, when Scott started his work, but if it had been, this would have been a case study of why GESDA was important. Because if you think about it, this was last century when this work started, with basic science invested in over years and years and years that nobody took any interest in. It was high risk, it was difficult to get funding for, nobody could quite see where it was going, However, were you going to persuade anybody, from a regulator, from the WHO, to a political system, to a society, that you were going to release more mosquitoes in order to control the mosquito disease? I mean, it just made no sense. And the lesson I think to take away from that is science that makes no sense today may make huge sense tomorrow. And if you don't invest in that basic science, you will not have the breakthroughs of tomorrow. But you can't just do the science. You have to do the science in the context of the societies it's operating in and the political system, and science is political, and you have to do it in the context of the regulatory and the guideline committees and everything else. And to pay tribute to the World Mosquito Programme and Scott himself, which he has not talked about, despite that apparent ego, which I haven't really seen before, but what he hasn't talked about is the societal engagement that has gone on over the last 20 years in, Northern Australia, but in Vietnam, in Brazil, in Colombia, in parallel, not in sequence, with some great science. And to me, that's the most important lesson, that unless we bring these together, and we do it over the long term, we will not have the breakthroughs of tomorrow if we don't invest in this basic science today.
We'll come to this again. So let's take your hat of Wellcome Trust Director now. When does an institution like yours might jump in? Because everybody understands that releasing millions or zillions of mosquitoes and growing them in the lab first costs a lot of money. So at one point, do you decide, okay, that's a project that the Wellcome Trust might need support in terms of supporting the cost of deploying?
Yeah, and I don't take credit for this, because this was actually funded long before my time at Wellcome, with, I think, some inspired decisions. But Wellcome is a philanthropy amongst many others in the world. And firstly, its role in the world is really important to try and define and be transparent about. It is not there to do what governments should do. It's not there to do what industry should do. It is there, though, to be at the boundaries of what the knowledge space is and push them further and take greater risk and be willing to invest over the long term in technological advances, scientific knowledge, but also making sure that that science is put into the context of the societies that's operating. I think that is the role of philanthropy, risk-taking, long-term, and putting things together which others in relative silos may not see the benefits of bringing basic lab science, societies, politics, culture, and regulators together.
But in other words, you say we rather finance basic fundamental research than one precise project on one topic, like growing mosquitoes to fight dengue fever?
No, I don't think you have to you don't have to make that distinction. What you're trying to do is make the biggest impact, as Sumir said. You're trying to make, in our situation, the biggest impact ultimately on health and health around the world. And in order to do that, you can't just do the science, at my view. You can't just be the regulator or the political system. You have to try and bridge those together. And where do those bridges happen? In a very fragmented, siloed world. And I think that is the role of philanthropy.
Good. So let's address one point that was raised by you, Dr. Sumia, equity, right? We've seen a dramatic inequity in the access to mRNA vaccines in the recent crisis. So how to make sure that this new technology is ubiquitous, accessible to all of us, all who need it on Earth? Whose responsibility is that? Yeah? Yeah.
I can start, and I'm sure others will want to come in.
Yep.
It's a very good question. Whose responsibility is it? And, you can answer that in many ways. It's the responsibility of the developer, I would say, who wants to have impact. It's the responsibility of governments. It's to protect their population. So governments that have a high rate of a disease must invest in controlling that disease, must invest in research and innovation and in implementation of the programs. I think they probably have the biggest responsibility, I would say. And then global organizations, that support either research or that can have an influence on policy, like, Jeremy was saying, on COVID-19, you saw that many global health agencies, including the philanthropic organizations like Wellcome and the Gates Foundation and, Rockefeller in some instances, came together and said, this is a problem for all of us, and how do we deal with this? So we don't have to wait for a pandemic. There are many other public health problems. Dengue is definitely one. It causes a lot of mortality and morbidity around the world. Tuberculosis is another one. Malaria is another one. I mean, we have many public health challenges where I think we could take a similar approach. But I do think, just coming back to the equity question, that I did mention the developers' responsibility. Once, of course, they invest, Scott has invested so much of his time and his life to this. And the biggest reward would be to see that it's used widely. And then, so if I were in his shoes, I would be thinking about, how do I build that capacity? How do I empower people in different places and different countries to replicate this technology rather than hold on to it and be the sole provider? And I don't know what your plans are, but I would think that once there is proof of concept, once there's a WHO guideline, this technology then needs to be transferred.
How? I mean, it's an easy word to say, but how?
It can be done because there are institutions and labs in many countries that can be trained to do the techniques that, obviously very carefully developed over many years in his lab. So technology transfer is a process. It's a process, but it can be done.
So let's ask Scott, because so what's your point of view on that?
I agree completely. I think what I want to see is the technology used. I'm just an academic, like so many others that dream of immortality through our work. And the way to realise that is to see what we've developed over the last 30 years get used. And so, but I think the difficulty with it is that what is this thing that we've developed? I always see the word vector control. We're in the vector control bucket, but we don't actually control vectors. We do something completely different, but we get lumped into that bucket with all the people that spray insecticides and do outbreak control very simply. And so there's an immediate thinking that the technology is simple to implement, but actually it's a technology that's quite technical to get implemented and expensive at the front end, and then it pays back over time because it's sustainable. But that's not like existing vector control. And so the issue, I think, that's an interesting one to think through is how does that capacity build happen? It's either like people like Jeremy and the big foundations are going to pay for that, or we have to find a way to be able to get some sort of revenue stream so that we can go to countries that can't afford the technology and to be able to train them and to show how to use it. And I think that little bridge that's required is a bit of a tricky one. And the foundations always, no offence to Jeremy, but they always want to kick you off their books as quickly as they can so they can get the next great idea coming along. And we're trying to hang on for funding so we can get this thing over the line. And so there's no obvious place for me to go and say, this is the money that would be required to do the capacity build globally. Where are we going to get it from? If it's not going to come from selling something to somebody, who's going to pay for it? And so that's the challenge I think we have to walk through.
Jeremy, and then...
Yeah, I think it's worth coming back to dengue for those of you who... Dengue is, and I worked on dengue in my previous life in Vietnam, and it is for me the sort of archetypal disease of the 21st century. It is very sensitive to very sensitive to climate change. When I first went to Vietnam in 1996, there was no dengue in Hanoi in the north because it was not tropical. It is now endemic in Hanoi. You said it's not in Switzerland, that is true, but it will be in southern Europe. It is across a much wider belt. It's urban, it's not rural. The world is becoming urbanized. The mosquito is beautifully adapted to it. So dengue is a disease which at the moment only has potentially one vaccine, which we're not sure quite of its impact. Dengue is something which is a harbinger of much bigger things that are changing in the world around climate, urbanization, trade and travel, which is underlying, of course, also epidemics and pandemics. So I think to get dengue right would set a precedent for how we get a number of other things right.
Arnaldo, you wanted to add
I
something?
would like to say some comments about this point about the equity and how we can adopt the new methodologies. There is an expression that we are used to say the from bench to bed. And I think that, not exactly to bed, but it's Slovakia is a good example from bench to the environment. So I think that it's quite important when you see a new methodology with this. It's not easy. It's very expensive, but it's sustainable. As you see, the results that we have in Rio de Janeiro, 90% of the mosquitoes is still with the Wolbachia after all these years. So we have a sustainability about that. And when you talk about the effectiveness of the studies with randomic clinical trials about this methodology, in Belo Horizonte, there's another site that we are using the same method. We are developing a project to analyze the randomic population of mosquitoes for we analyze the effectiveness of these methods as well. And I agree, and I decided, and I'm quite sure that it's necessary the government invest in new methodology. Because as you see, as you know, and for the reasons of this summit, we're looking for the world. And the place that we live today, we want the place, it's a good place to live for the future generations. So we have to decide a methodology that can be sustainable for the next ones. And I think that I'm just finished. Yeah. I think that we have the pandemic lesson learned. Sometimes I have the feeling that in spite of all the suffer that the world have lived the last 2 years, we need to understand how many lessons we have learned when we think about the world. So it's quite important that we have a more equitable world for the people can have access to very good health and very good well-being with the disease that are completely controlled.
Let me come back on this question of endorsement, right? You mentioned the process at WHO. If you listen to those two gentlemen, it seems like it's working. So why does it take so long? Why don't you speed up the process in a way? Maybe first question. And then second question to you, Scott. How important is that step of endorsement? I mean, how will it help? So obviously Brazil didn't wait, but other countries are more reluctant to apply the technology, maybe because they are waiting for an official endorsement of WHO. So how important is this official endorsement by WHO? So maybe first you, Soumya, and then Scott.
Yeah, so this is interesting about being fast. And in fact, during COVID, there was always this tension between trying to be as quick as possible with making the recommendations, but also making sure that you have enough data backing that, because WHO recommendations, I think, do have impact globally, and you can't afford to, in an emergency, people might accept, that you can be wrong and then you have to correct yourself. But again, I think we have to look at safety as quite a primary thing for us before we make. So for the drugs to treat COVID, there was huge confusion at the beginning, and everybody was trying every drug, and the clinical trials were small and not answering questions. And so we had to address all those issues, and then we set up the living guidelines, and we've looked at all of the different drugs, ever since used. And most of them, in fact, the recommendation is negative, saying this drug does not help COVID, please don't use it. Now, making the recommendation is one, and then using it, applying it, implementing it is another. So of course, the WHO's role is to provide evidence-based guidelines in as timely a fashion as possible. But if there isn't good evidence backing it, then the guideline development group does not feel comfortable. And I've recently been in discussions with the malaria group as well, where there's a question around safety, and there's a lot of discussion going on, and the need to wait for more data coming in. This is for early pregnancy. But in this case, once the guideline is made, then you get into we may get into the supply issue. There could be a situation where many countries are asking for this. And so I think we have to be prepared and have a plan as to how we're going to, this is where the tech transfer and other methodologies would come in. And of course, the funding would need to be found. But also we have to look at preparing communities. In this case, both Scott and you mentioned, Arnaldo, that communities will be confused if the government comes in with releasing mosquitoes.
We'll come on. Well, yeah,
we need to prepare that. But the last point is that the guideline is not going to be the end. it will be updated. And therefore, we need to continue to collect data on how long does the Wolbachia persist? Does it continue to be effective? And are there changes, that happen in the mosquito behavior of the mosquitoes or any other? Because we have guidance out on gene-modified mosquitoes as well. There, of course, you have to be even more careful because you're introducing genetic changes that are going to persist in the environment. And so the ethical and regulatory frameworks in countries, to do these things is very important. To promote innovation at the same time, you have a system of collecting data, feeding back, and if you have to, at some point, pull back on a new technology because you've got new data, then you have to be willing to do that. So.
Scott, when we met first, I was in February, I think, this year, you told me about Brazil, the good example. You had other less good example of governments being more reluctant, right?
Yeah.
How important is for you this endorsement step that is?
I think the WHO endorsement is hugely important, hugely. And while it might take some time, what we want out of it is the rigor of it. So we want the technology to really get looked at closely and have a very high bar for acceptance. Not every country is going to wait for that, but there are some countries that probably need it because they don't have the internal capacity to make an independent review of the evidence, or they're really looking for help to know which way to go. Other countries not. Some countries like Brazil, potentially an early adopter. They have their own internal capacities very high. They're already spending large amounts of money on dengue control every year. It's a high priority political item within the country to be dealt with. And so in that situation, they're probably not going to wait. And so you're going to get this staggered thing happening. And we find some governments are a little bit more risk averse than others. We have early adopters and ones that hold back. And the WHO is critical for the ones that are holding back.
Thanks. And what about philanthropic institutions, not the Wellcome Trust by itself, but in general, right? Do they wait for such a, say, security check before deciding to invest in such a new technology?
Yeah. There's two questions there, I think. Sorry. I agree with Scott. The WHO endorsement is really critical. There will be countries. Brazil is an example. I would argue, actually, Vietnam has historically been an example of a country. And when a country is faced with every year seeing massive outbreaks of dengue, you can understand why people would make decisions. And Brazil has a very good regulator, Vietnam does as well. So there will always be early adopters, but the WHO endorsement is hugely important. But I think it does come back to the sort of topic of the next 2 days, which is technological advances are coming. We need to focus on the technological advances that are in our hands today, but we've got to make sure we're thinking of the technological advances 5 years, 10 years and 25 years time. Scott started this work 30 years ago, and you had to lay out a pathway of what that regulatory pathway was going to look like, because it's not going to look like your traditional vaccines. It's not going to look like your traditional drugs. You're giving it to a community, most of whom may never get dengue. That's a really big ethical and regulatory challenge, and that will be a lot of the innovation that's coming in the next 25 years, I would guess. So I think we've got to rethink how we link the scientific community, the regulatory community, how to pay for it and make it equitable, but also the political community, so that we bridge these gaps, which frankly, in many parts of the world are increasingly diverging.
Any comment on that? Otherwise, I think it's a good moment to open the room for questions. Yes, I see one here and then one there. So there's a mic. There should be a mic. No, please wait because you're online as well.
Good evening, and thank you very much. Fascinating discussion. I wanted to pick up on a couple of points you made around societal and regulatory engagement and take that beyond the question of VBDs. So for instance, Dr. Swaminathan, you talked a little bit about the challenges around COVID-19 vaccines and the rollout of that. And I think, Scott, you talked quite a bit as well, Jeremy as well, about the importance of the parallel societal engagement when you rolled out this process. Now, when you start thinking about the other big health challenges like NCDs, non-communicable diseases, health and lifestyle diseases, where both regulatory engagement as well as societal engagement is critical, because most of the solutions aren't actually going to come out of the tip of a needle. How do you actually use these lessons and translate this into that level of engagement around the bigger lifestyle diseases we see coming ahead of us?
I'm just going to take it.
I'm not sure how to answer it other than to agree with you. Look how the world is changing. We talked about dengue and the disease of the 21st century, but look at the other demographic shifts that are happening. The non-communicable diseases that you talk about, whether metabolic or cardiovascular or oncology, the answers to that are going to be partially technological and they're going to be partially behavioral. And again, if I come back to the sort of theme of my comments really, which is increasingly our worlds are fragmenting, not coming together. Our social science world doesn't necessarily have the culture and language that the technological world has, and vice versa. And if we keep training people into silos, then we will end up with siloed responses. So I think we have to sort of take a step back and say, how can we make sure we have sufficient number of people who are the humility to work across interfaces and across disciplines, because ultimately the Wolbachia intervention is a technological advance, but it's going to require massive social science understanding, community involvement and co-development, not just engagement, and political and regulatory. Unless we can bring these together, then we won't bring the innovations to the maximum number of people globally.
I want to endorse that and just say that, on these complex challenges that we're going to face in the future, you need the interdisciplinary research, and that really needs to be encouraged in all countries. We tend to neglect the social and behavioral sciences, thinking that technologies and biomedical innovations will solve all our problems, and this is clearly not true, and you gave a very good example. The WHO now has a behavioral insights, a technical advisory group, recognizing that just making public health announcements or telling people to do this or that is really not always the successful way to do things. You have to understand what are the levers that can help change people's behavior. And there are policy levers, but obviously there are other levers as well.
I think there was one question here in the front.
Thank you very much. As a social scientist, I had a question about education, actually. Arnaldo, you were talking about the importance of education in enlightening the citizenry about the shift from killing mosquitoes to spreading more mosquitoes around. And I was wondering, did you encounter any resistance in that public health campaign, and any lessons perhaps that we can learn for future public health interventions, or perhaps even kind of vaccine hesitancy? And if I may, I have another quick question. Just round about the variation in results and the importance you mentioned, Scott, of temperatures and high temperatures and the effectiveness of releasing these mosquitoes. And I was just wondering if there are any other natural obstacles that you encountered in the natural landscape and the ecosystem of other insects, and will the effectiveness of this intervention, do you think, change with climate change?
On the questions of acceptance, and then also Scott,
yes,
because probably
it's a marvelous question. This is a marvelous question, and I discuss a lot of this. I always to say that release mosquitoes in the environment is not the last step, but is the middle step, because we have to plan, to design a plan. And the design, this plan that was designed, it's necessary. The first step is to understand the territory that we are going to select, based in the epidemiological data, based in climate situations, and something like that. So we have to study the territory that we are going to release the mosquitoes. After that, there is a factory that is making the mosquitoes with Wolbachia, but there is a very important step when we have a lot of meetings with the community, explaining the method, explaining the methodology. So we have several social agents in the communities with several meetings when explaining education for them, for them to understand that they don't have to kill these mosquitoes, because they're not the bad ones, but they are the good ones. Perhaps? Do you see what I mean? So it's quite important, this step, these several meetings with the local health agents, with the community, for they understand that one day we are going to release the mosquito. And after that, we are going to collect the data, we are monitoring the mosquitoes and to do all the studies, all the data that is necessary for we understand the method as well. But this step is quite important, because if you don't do this quite well, the method is not going to be as successful.
Scott, probably you agree?
Yeah. When we did our first experiments in Australia, we went to a community in Australia, 2 communities actually, and we were going to, for the first time, release mosquitoes that a bunch of scientists in the big city down south had said it was all going to be okay. And not only was it all going to be okay, but it's going to fix all your problems. And never mind that we're going to release mosquitoes that are going to bite you, and they're going to bite your elderly mother and your 6-week-old baby. And I had just received recently the largest grant I'd ever gotten in my life. And my job, one way I think about my job is a professional beggar. And so I was horrified that I was going to get one shot at doing something, and we had one lot of money, and then the ride was over. And so there's a lovely case study of work that was done in the 1970s in India around genetic control of mosquitoes, where the whole program essentially got closed down and thrown out due to poor public relations, community acceptance issues. And I wasn't going to let that happen to us. So not only that, one of the cities we're going to release into, our first city, was the location where the cane toad was originally released in Australia. So if you have some knowledge about Australia, you understand maybe the significance of that. But there's a little playground next to the pub there, Cane Toad World, and that was the community we were going into to do it. So I went in, we put 25% of our budget against community engagement at the beginning because we thought it was quite important. And I maybe was a bit cynical. I went in there because I didn't want any opposition to our work, my one shot. And but I have to say, my confession is, I found, not having no background in social sciences at all, and having never worked with the community, then doing this project, I saw the immediate power of it. Just the power to make things happen when you work alongside the community rather than in some laboratory, and then you come out and say, this will be good for you. And so, I became a huge believer in the importance of the community engagement and doing it side by side, so I just want to say that. But with regards to temperature, yeah, we've found in some locations that temperature, extreme temperatures can be problematic, and so that's been documented scientifically. We've seen it in the field as well. And is that going to be a huge problem for the technology? I don't think so, because most of it's not the constant temperature that's the problem. It's when you get the really blazing hot summers that are up in 45 or whatever degrees that you start running into problems. And that's usually when you get into the more temperate areas or the subtropical areas, you start seeing seasonality start coming in. But in the tropical belt, where we have most of the disease burden, Indonesia is like an incubator. It sits at 27 degrees. And so, it's an issue up on the fringes. And I'm sure there will, as it's a biological system, it's living, it's going to change. And so we should expect there will be changes and limits to the effectiveness of any technology that's trying to intervene in a biological process.
Scott, before giving you the word, just a follow-up question. And you touched on it. Actually, with climate change, the distribution areas of the mosquitoes will change a lot. And so the mosquitoes in Brazil might go to Venezuela or Colombia, even though there are already some mosquitoes there. I want to touch a question dear to GESDA as well, which is say, the global multilateral collaboration. So we've heard about your government, but how far all of you see the necessity for governments to interact between them and act together to address this big question. Is there a need there, or do you tend to say that governments have to act, by themselves for their own country?
I think it's quite important. Scott, let me start first. I think it's quite an important question because, as our friend Tedros said, Dr. Tedros said, no one is safe until everyone is safe. Because in spite of we have borders, we have passport for you go another country, for one country to another one. The mosquitoes, they don't have passport. They don't recognize borders. So it's quite important for you have a region safe, a region American safe. It's quite important all the Americans to be together, working together.
Is that the case?
Yeah, I think that is the case.
Are you approached by other governments?
Yeah, the approaches for that.
Yeah.
So in Brazil, we developed a project now that we call Vigiar International. That's Vigiar. It's not make sense in English, but in Portuguese and in Spanish, it's quite important because it's alert response, surveillance alert and response, and we are training all the countries of the experience that we have accumulated in Brazil, because we think that it's quite important to have a region safe.
Sumia, do you think WHO should have a very active role in this?
Yes, and I think it does happen because we have our regional offices and there are many programs, many control programs that the regions take pride in actually working together. For example, you have one region or the other that declares measles elimination or polio elimination. So this is a good approach to dengue as well in the future, malaria. So yes, there's a lot of regional cooperation. In some cases, I would say you need also global, because you may have disease endemic countries in different parts of the world. I mean, tuberculosis is a good example, right? Where it's not necessarily just one region that's impacted, but yes, it's important.
So I'll take a few questions together because time is running. So let's take this one and then Monsieur, please.
Thank you very much. I was captivated by this talk. I had two questions. One was, what is the scope and potential for this technology, perhaps with other mosquito diseases or indeed in other vectors? The second thing was, it really sounds like kind of a win-win, almost a panacea, but have you anticipated any kind of unintended consequences, be they ecological, societal, etc.?
And let's take the question there as well. Then you choose which one you want to answer.
Thanks very much. I'm Graham Alabaster from UN Habitat, and we're involved with WHO on the Urban Malaria Framework, and I'm part of the Lancet Commission on Aedes in cities. I wanted to ask, Habitat works with local authorities and local governments, and we see that as a very important actor in managing vector-borne diseases. I'd like to know from the panel what they think about that approach. The management of these diseases is definitely multisectoral. It's not to be left to the medical sector alone. And I'd like to ask what the panel's feeling are about that. Thank you.
So let's start with this one, and then we'll come back on the unintended aspects, maybe.
Well, I can just say that we work with local government wherever we work, because usually they are the people from the community that know the community that can give you fast access to the community. And so in Brazil, we work with community health workers in the cities we work. In Indonesia, with health cadres, and that local level, I think, is critical. And in many countries, the local level holds the money for control as well. It's not held in the capital.
Maybe I could just add. I think you raised a very important issue because I think it's not appreciated that about 70 to 80% of your health or health outcomes are related to the social and environmental, economic determinants and not health care. So even if you keep on improving and building better and better hospitals, the people may still be suffering from ill health because of the housing, the nutrition, the diets, the water, sanitation, etc., the which surrounds them. And so I think this approach to health, where you're really addressing the upstream determinants, air pollution, for example, taking years off people's lives, at the moment. So habitats are extremely important, and the way people live, and especially in cities today, we talk about non-communicable diseases, but if you don't have any opportunities to walk or cycle, then you really can't tell people to go and exercise. It doesn't make any sense. And similarly, if you can't afford a nutritious diet, then all our guidelines, are not going to make any sense. So this is, again, the multi-sectoral, intersectoral approach to health, which governments have to start addressing. And again, these are complex.
Just on your, I would counsel against anybody thinking any intervention is a panacea. Even Scott, I think, would not argue that the whole innovation for dengue for the future should stop with Wolbachia, because there's almost nothing which can be solved with a single intervention. The second is, this mosquito does more than dengue, Zika, yellow fever, and other diseases, chikungunya. And whether, I don't know, Scott, whether this would be applicable to Culex mosquitoes for Japanese encephalitis or not, but,
Should be.
but that, of course, is being looked at now. But I would avoid the sense of a panacea. You're not going to solve dengue with or any of the others with a single intervention, in my view.
Yeah, I agree. I think we can have very large impact, but I think it would be foolish to put all eggs into one basket. Yeah.
Scott, unexpected aspects of the technology that we haven't mentioned?
Adverse, do you mean? I can't remember the question. We've been monitoring to look for anything untoward very carefully everywhere we go, and so far we haven't. I think part of the reason that I feel comfortable with that we haven't been able to find anything negative is this thing is already all around us. It's in 50% of the insect species naturally. So, it's insects that are living on your body probably have it. Insects that you're eating probably have it. Even many of them you don't even know you're eating in the food supply. And so we're surrounded by it. And I think for it to be in that situation, I don't think it can be having the huge unexpected negative consequences. And just to finish on other diseases, not work we're doing, but other groups are getting very interesting results with malaria and nematodes as well. It looks like it's impacting their ability to live in the mosquito. So it could, not from work we're doing, but other groups, there might be expansion into other areas in the future. But malaria is a much more complicated transmission system than dengue is.
There are two questions here, and then one at the back. First the two, and then at the back. Yes?
Thank you so much for the lovely discussion this evening. How long does it usually take for the WHO to endorse a technology like this, especially when the site of clinical trial or data collection is so fragmented across the world and its effects are spread across years? So how long does it usually take for the WHO? What are the considerations for the organization?
Let's take another question, and then we'll have the answer, and then we go to the back.
Thanks very much. I agree. It's a fascinating concept for GESDA, I think. So these are very complex interventions that are happening in complex systems that are changing very rapidly, unfortunately, now. So I'm just wondering if there's an opportunity to link up like long-term ecological research. There's lots of investments in places. Longitudinal studies, not just in health of human populations, but longitudinal studies of natural ecosystems and the built environment, coupling those together with maybe these sites that are going to be early adopters, where you really need that evidence, and how can we get that evidence much, much more quickly, really high quality evidence, which means long-term studies across all disciplines. We can't do that globally, so probably picking some places where you can do that. There's places you guys have been working with already that are early adopters. How can they be maybe supported more? And just a final question is for Scott, maybe specifically, are you continuing to work with those communities and thinking about the next set of technologies that are coming, which might be genetic modification or other approaches that this could maybe pave the way to, at least with people who are engaged to understand the issues, and is there something new now that we can do? because this won't be, it's not the panacea and it won't be the last technology. So are you paving the way for future technologies and hopefully not actually burning those future technologies, which would be a risk, right?
Yeah.
So being aware of that.
Yeah.
There's another class.
So, just to answer that, we're not directly trying to support other technologies further up in the pipeline, if you like, but we are indirectly doing that. And, I think it'll be much easier for communities to be accepting of other mosquito release programs, even if they have a different underlying technology based on the work we've done in countries we've done. I think it's not as outlandish now as it used to be. So indirectly, I think we're helping. I would also say long-term ecological studies, I would love to see them happen, love to see the ecologists doing that, and particularly on sites. We've essentially done one of the biggest co-evolutionary experiments the world's ever seen. We've set it up. It would be lovely for someone to track it. We're not doing that. I'd love someone to do it. The problem is getting long-term funding is always problematic, and long-term monitoring requires long-term funding. Yeah.
Sumia, let's come back to the first question, maybe this timing questions again.
Yes. So the timing question, there's no one answer, right? It's not like everything takes 3 months or it takes a year. It varies depending on what you're assessing the technology. If you have high-quality randomized trials, then like we saw in COVID, we were constantly updating the efficacy of hydroxychloroquine or of remdesivir or of a monoclonal antibody, and we were able to make very clear recommendations. Now, in this case, I think the VCAG, the Vector Control Advisory Group, has been discussing with Scott's group right from the beginning, from the time when looking at the study design and saying, yes, this design is good, and we further would encourage you to collect data. Because for vector control, the thing is that it's not enough to show that you have made a change in the vector behavior. You have to actually show that there's an epidemiological change in the disease. This applies to malaria as well. There are many new innovations for malaria control, but you actually have to implement and do it in the field and show that malaria incidence is coming down, or dengue in this case, and then there are no other unwarranted effects. So I think those discussions we've been going back and forth. There have been recommendations made onto the type of studies, and I think in the most recent interaction, again, there have been some additional data points that have been requested from the group. So it's an ongoing, healthy discussion, and at some point, the guideline development group will decide that they can make a recommendation for or against, but it's never a final, it can be always modified based on incoming data.
Thank you. We have one last question here.
Yes. I'm Solima Kolchiso from the Central Tech Center at TPFL. I just have 2 quick questions for you, Scott. You showed these 2 populations of mosquito, one on the left, the black ones becoming all totally blue. And now the question, what I didn't quite understand, what's now stopping some sort of sporadic invasion of that steady state, so to speak, and then with whatever other type of mosquitoes, which might eventually bring you back to square one or something else. And the second question, I also, you showed the distribution of dengue fever across the world. And one of the pictures right in the middle actually was Central Africa, which is probably the poorest region in the world, which is also highly affected by dengue. And I'm just curious, when I looked at the studies that were carried out, actually there was a big, how come that region, and because it's actually also linked to the question about equity, access, etc. So I'm just curious as to were there any specific challenges that led to that particular region being overlooked, in the selection of your study sites?
Yeah, I don't. We haven't overlooked it. I think there's been a couple. Firstly, that distribution was a modelling prediction, not actual disease burden. So we need to be careful of what we infer from it. And I think that the general feeling is burden of dengue in African countries is still being worked through. I think it's clearly there, but to the extent how extensive it is, I think we'd love to see more data on. why are we not working in African continent? Have you ever tried to catch a flight from Melbourne, Australia to X country in Africa? And it's very difficult to do and long, and just the inconvenience of the travel has made us work in other locations in Southeast Asia that are much more proximate more quickly. Although now we have set up an office in Europe, which Olivia sort of referenced. I'm living in France at the moment, which allows a group of us to be in a compatible time zone. And actually we have a team in 2 African countries this week talking to governments about the possibility of setting up demonstration projects in East and West Africa for countries to be able to examine the technology themselves.
And before giving you the word, the risk to go back to square one?
I'm sorry, I didn't understand
the risk to go back to square one, meaning this invasion
sorry. So, Olivia said you can have 3 slides and you have to have 2 minutes talking and that's it. And at the beginning, because we want to have this discussion instead. And so I didn't put all the technical slides into the deck of me presenting at the beginning, but there's this really amazing thing that Wolbachia does that I didn't talk about, and that is that it is only vertically transmitted through the ovaries and the eggs of the insect, and that is done in such a way that females that don't have Wolbachia get disadvantaged in a population, because when they mate with males that do have Wolbachia, all their eggs die. And so if you're a female with Wolbachia and you mate with a male with Wolbachia, your eggs don't suffer that fate and they live normally. And so this allows Wolbachia to spread into a population once it's above a certain critical threshold, and prevents it also from being reinvaded with uninfected mosquitoes from the outside. So that's the key element of why this technology is sustainable, and you apply it once and then it just keeps going, because the Wolbachia actually maintains itself in the insect population.
Jeremy?
Can I just defend that modelling paper, because I'm an author on it? It was bloody good.
Yeah, so I got
good. The question about Africa is a really important one. If you look at the history of dengue post-1945, the spread has been driven by urbanization and trade, and Southeast Asia was the home of it to begin with, actually. Then it was Central and South America, and then as a result of urbanization now going on across the continent of Africa, and it's a shame Amadou was not here, my prediction would be there's going to be a very, very significant increase in dengue across the continent of Africa in the coming years. Remember that for dengue to get hold, it really has all 4 serotypes of dengue has to be present in the community in order for it really to get, and that's happening. And if Amadou was here, he would explain how that's been happening in Senegal and many other countries of West Africa.
So unfortunately, we have to come to a close, but before that, shortly, we address this very specific topic or story of the Wolbachia, but what is your take-home message, each of you, to what it says about how to address that question of fighting vector-borne diseases? Who wants to start? And short. Jeremy?
For me, the bigger take-home message is technology is coming, and let's think ahead of how we may use it in the communities that are going to be most affected. And think not tomorrow, but think 5 years, 10 years, and 15 years out, because at least some of it you can predict.
I would add on to that and say, if we can predict technology is coming and we know it's coming, is there something we can do more systematically about that transition from the bench to the field, if you like, about how do we get the capacity build for new technology globally? How do we actually prepare for the uptake of those technologies as they come? And I think that's a key issue that we're seeing that makes me worried about our technology, but I think it's broader than that.
I think that the message that I would like to leave, that the government must have the commitment and to think in new methodology and to improve the public health, because every life counts. Every life is very important. So when you save lives, even so with the disease we were talking about, and now we're talking about the Huban arboviruses, but in the different disease, it's quite important the commitment of the scientists, of the philanthropic institutions. WHO has the guidance for everyone, but it's quite important the government to be united before we going forward, to push more and more for we have a safer world.
Soumya, you have the final word.
I agree with everything that the panelists have said, and I just want to add that I think science and innovation are going to give us a number of exciting solutions for our or at least they have the potential. And so we need to make the links like WHO has done. You know, it's traditionally a public health agency. We now have a science division, a chief scientist, and connections with scientific communities around the world. I think that helps to bring science and public health together. And then, of course, we have to look ahead. And as other panelists have said, there are many issues around the ethics, around societal acceptance, around regulation, and of course, around funding and cost effectiveness. And we have to start thinking in advance so that we can ultimately get those solutions as quickly as possible to the people who need them. And then we have to keep equity in mind, because there's no point science developing solutions for some people in the world, and lots of people don't have access. That's not the world we want to see. Thank you.
Thank you very much. So 3 final things. First, a round of applause for our speakers tonight.